So today we're going to be doing service on an ink valve. So this is just a ball valve, and there's three parts to it. So this is the actual ball itself. So this is based off of a simple ball valve where like you would have a handle and you would turn it. So there's a ball inside of here and it'll turn on and off. So this is a spacer that ties these two pieces together, and there's a hole in the bottom. So we got a Prox right here. So this can see the arm that's going across, and it will send a signal back to the station to let you know that the valve is actually turning on and off. And this is the pneumatic actuator. So it's just a little rotary valve that attaches to the ball valve that will turn the ball. So it's an air-activated ball valve. This is a 5. Yeah. There's a couple of things that can make these go bad. The most common thing that goes bad is that this ball will wear down where it seats. It will allow ink to pass through even when it's off. So that's a big problem, and that's one of the main reasons that we take this off. The other thing that could happen is ink could actually go past this seal and start gumming up the air actuator so it doesn't turn on and off fast enough. Or if it just starts drying up and it doesn't allow it to activate properly. So what we really do here is we're just going to take it apart, replace a few components, clean it up, put it back together, and test it. So nothing too awful difficult. Okay, so we do have some ink through here. So that means that ink did actually pass through the seal and end up into the air actuator. So that's not good. There's a spring that sits between here and this ball, so it compresses it and keeps it in place. So when we take this off, we need to do it slowly. There's two bolts, so we just need to loosen up one, then loosen up the other, and go back and forth slowly to make sure that that spring doesn't make anything get crooked. So here's the top half, here's the spring, we got a gasket, and then the ball is sitting right here, so we're going to force that through. It's going to take an Allen. There we go. So here's one seal and the ball. And there's another seal on the inside, so we got to try to pull that out as well. So this is essentially what we got. There's two seals, and then the ball sits between them, and all this really is the housing where all that happens. It doesn't have to be perfect, it just has to be fairly clean. We don't want any ink to be sitting inside there and then dry up and cause problems when we go to install it. So right here, this yellow ring, this is what's supposed to seal this. But as you can see, it's popped out. So that's why ink was able to travel through it and into the air actuator. There you go. That is the failure. This is also springs. So the spring loaded on both sides. There's a spring here and a spring here. Each one of them up a little bit and keep going around because I don't want it to bind. So inside this chamber it should be clean, or somewhat clean. It's not going to be, but let's just see how dirty it actually is. It's actually not too good. No, it's got plenty of ink in it. She is sludged up. The good news is these springs are still in good condition. They have a tendency to break, but this one is good. Okay. We got something in here. It's like a snap ring. Got pieces of something. Spring, oh yeah, it's the internal spring. The internal spring on here is shattered. Yeah, so this one's no good. So these are the stops. So when this rotates, it's going to hit these pins, which is going to stop the rotation. So we're going to take this out. There we go. So there's your piston. So we want to make sure we don't lose these little pieces of plastic right here. This sits right here, and that provides a surface for it to slide up and down without scarring up the cylinder. Let's pick out this O-ring. It's a nice thick one. We're going to make sure we replace that. And there's a seal right here too, but we don't replace that. It's not really a seal, it's more like another one of those friction surfaces, so it's not scarring it up. Since we had pieces of metal in here from that spring, we want to make sure that it's not beat up to a point where we can't reuse it. You can kind of see where it's all scarred up. So this thing definitely took some abuse. As long as it's not scarred along this surface, it's okay. And I think we're okay with that. So we could reuse this. It's not ideal, but it's usable. All this is an indicator telling you which direction it is. So we're starting to get kind of a look at what we got going on. So you can see inside here. So when air comes in here, it fills this chamber, pushes those pistons up, and then that's what causes this to rotate. So the pistons are causing this shaft to spin, and then the springs push it back down. Just want to make sure that inside of here, because there were those busted up springs, that there's no scarring, but it actually looks okay. Now this isn't really like an engine where it's real fast movement, where everything be flying around. This is slow moving, so those little pieces could just sit on top of the piston and not really do anything, which is, it looks like that's what happened here. And here's our O-ring on the top. Pluck that guy out, and we're gonna have another one right here. Alright, so here's our parts. And this had a couple of problems with it. The first one is that the spring is toast. Right, so that was that guy right inside there. And the ball has a crazy ridge on it. So this thing is super wore. You can kind of see right around here. It's kind of got this extra bend. So this thing is super wore. Well, that's okay, we got an extra of those. These lifesavers right here, that's what we call them. We have 2 of those, so we'll replace that. But the biggest problem was this seal that allowed ink to pass through this separator into here and gum this thing up. So although I've heard of this happening, I've never actually seen it, and I've never taken this thing apart because I've never had to, and I've never been trained how to. So today we're going to kind of explore this guy together. That's not good. Alright, I'm going to have to come back to that. But when you pull the snap ring out, hopefully this thing will just push through. Nothing holding that. It might be just stuck on the bearing. That's what I'm guessing. Now I'm going to have to put some force on it. And it can spin all the way around, so that means it's not going to interfere with the Prox. I'll just try that. There we go. Okay. Yeah, so there's not really a lot to it. Just a bearing on this side, and then this piece of metal right here is read by the Prox. Here we can see that it actually had a seal in it. So it looks like that one just got shoved deep in, so they tried to put another one on top. So that was human error. So now we can kind of see inside that chamber, and the top of the Prox is basically flush with the surface there. And then when this thing spins around, that's what it sees. It sees that little pin right there. So since I just hit these bearings with solvent, I'm going to give those a soaking bath in some WD-40 to get them relubed. It's not going to be quite as good as grease, but this also doesn't spin very fast. or terribly often, so it's not that big of a deal. There you go. And so here we got a new seal, and this is a spring seal. So you can see it's got a spring on the inside that's going to force the outside apart. So the outside and the inside should make a good seal. I might load this up first. Drop that in. And so that's going to allow this to rotate, but also prevent anything from getting past. Alright, I'll just let that drain in.
You gonna open one for science?
I already opened it. When I pulled this snap ring out, it went and like I listened for about 4 seconds before it hit the ground. I have no idea where it was, so I grabbed another one. So these lifesavers just kind of pop out like this, and we put brand new ones in. Flip it upside down, press it so it's nice and straight. So these are ready to go except for this O-ring right here. It's always a good idea if you do this to replace the O-rings, partially just because we ran a bunch of solvent across them, so they're not going to be as good anymore. For this, I'm just going to use WD-40. We can use Molly Coat for this or whatever the heck you want. So we're going to drop this one in first. Kind of see how that fits right in there. And then we got the ball. We want the ball to be facing so that this slot can mesh up with this tooth. Okay, there we go.
Don't keep that lined up, you won't get it together.
Yeah. Spring. But I also have this one lined up so that it is solid. So this is currently closed. And if I want to open it, just put a screwdriver in, hit that slot, and spin it. And so now it's open. So now for the last piece. So inside here, there is a little cam that hits this pin. So this pin is sitting inside, and then this cam hits it. I guess you would call it a cam. What would you call that? A stop? A stop? That's correct. Okay, I guess you'd call it a stop. But anyway, it hits that, and then that's what causes this to stop rotating. And then we got one on the other side that I've taken out, but I just left this one here because I already know that's correct. So now we're going to put O-rings back on our pistons. Okay, and we're going to lube. And we're using double action piston. It's a 2-stroke. Betty's ESL 5 and 10 actuator lubricant. So this is designed for actuators, and we're about out of it. And you want to use a whole ton of it because this doesn't get replaced. However much you think you should use more. Let's coat the cylinder. Now we want to make sure that we've got these little plastic guys back on. and use a little bit of that grease to hold it. Okay, and we'll do the same thing with this one. And we don't want these to run into each other, so I've got one over there. I'm going to put the other one over here. Okay, this one's sucked in a little bit and this one's not, so they're not lined up properly, so I got to pop them both out. Right about there. So now they're even on each side. I'm going to pull them in and see if they're correct. Alright, so they do not look like they're in deep enough, so I'm going to have to try one more time. I'm going to pop it one tooth, so you can just hear it pop. Just like that. I'll try it again. Okay, so we're a little bit closer in. You can see how this is going up and down. And if I rotate it 90 degrees, it should go there without this popping out the side. So that looks good. So now, put our stop back in on the other side, and we'll get that adjusted. Okay. Because everything is sealed up now, we need to have a place for the air to go. Okay, so it is currently in, and it is out. And you can see when it's in, it's perfectly straight up and down. And when it's out, it is not quite perfectly straight up and down. So that's what this adjustment is. So we're going to go a little bit past. Okay. So now we're a little bit extra on the counterclockwise rotation. I'm going to rotate that in with this until I get it perfectly straight. There we go. That looks pretty good.
Hey, can you come over to the gumbo, please?
Can't work?
There we go. So now that's locked down. So we got our stop set for closed and open. So when it gets pressurized, it's only going to go that far, quarter turn. And this does have to be sunk in a little bit, just because this has a little lip, and that lip has to be able to fit inside. It's going to go like that. And we need to make sure we have that O-ring. Ourselves room, drop this on, and then lock these bolts on.
And they got lucky here.
How so?
When I ran the mueller at the Southwest Printers,
Yeah.
I had to bail by hand.
Really? How does that happen?
I had a baler somewhat like this set up.
Yeah. Oh, you had to wrap the wire around it and then tie it.
Yeah. Tie and all that crap.
Dang. Yeah.
It had an arm that you hooked on the bail as it went out.
Okay.
And when I got to a certain point, it stopped.
Okay.
Then you went out there and put the wires through it, tie it out, all this crap.
Wow.
Every once in a while, the arm would flip, and I would have a 20-foot bail.
No kidding. Damn. What do you do with that? You have to. You have to separate.
Refeed it back through.
No kidding. Wow.
Their setup was outside.
Yeah.
My other was outside.
Yeah. I can see that. A leaf blower? Yeah.
One of those leaf vacuums in the bag. We tried one of those. Over at Mac Printing, they had the same setup, but they had made the box out of that press board with the holes in it. They made the box catcher. So they had a vacuum
kidding.
Yeah, nothing but paper shavings.
Wow.
We were jumping in it, climbing in it.
Yeah. I bet.
So with that, I would just take the clamp truck,
Yeah.
grab big piles of it, take it to the back of the building, put it in the baler.
Huh.
Paper shavings.
Okay. There we go. Okay. There's an air leak, but it's this right here. Yeah. An air leak coming out of the exhaust, is that not normal? That is normal? That's fine.
It's down, got converted.
Okay.
See how it's losing it?
Yeah.
Really stay open.
Sure. So as long as it's not like losing a bunch of air, it's not a big deal. Okay.
That's all it does.
Alright. So this one works. So right now it's off. We need to make sure that we have the ball also off. So it should be closed, and it is closed.
We've done that. Somebody's done that.
What's that?
Put the ball in backwards. Or when it was off, it was actually open. Who did that? Somebody did that. Somebody did that. I
I think a
know.
lot of people have done that.
Before I started, I took a picture just so I know how to put it back together correctly. And so we've got this pointing that way. So that means this should be facing like that. It should be like this. And then the spring is going to go like this. So this is the orientation everything should line up. So this is kind of a socket and this is a square. So we're just going to kind of straighten that out and it'll drop right in. And then we just need to make sure that that ball with that slot is centered so that it will line up with that pin. It is a little bit wider than the pin, so you've got a little bit of play on it, but not a ton. There we go. Just drop all the bolts in.
Got a new yellow seal on it?
Yeah. Why was there was two of these? Don't forget that. Don't forget that. Okay, and that's a ball valve. So for the final test, you're gonna make sure the whole thing works together and that the Prox turns on. So this is just a little thing that, what was his name? George Vasilio. Joe Vasilio made. And all this is a 9-volt battery. I think it's 2 9-volt batteries. So 18 volts. I think this takes 12 volts. And so he's got that set up to power this Prox so that it will light up. So we can actually see that it's turning on. There's a little light right there as soon as this turns on. So we got a red light, so we know the Prox is working, and it is open, and this is open. So everything is working the way that it should. This closed, and that closed. So there we go. So it wasn't holding pressure, and I think that one of the problems I had is that this O-ring is too damaged. It's still on there, but it is very flat. So I'm going to replace that. There we go. Oh yeah, leak is gone now. So at this point, With it pressurized, it should stay closed for, what do you say, 20 minutes?
You almost gotta cycle it every 4 seconds.
Yeah. So it's not even really critical, but it's just a way to check to make sure that everything is properly sealed. But when it's done, you just relieve the pressure. There you go. And that is complete.